Thanks out to Brad McManus and Georgia DOT, as well as Georgia Tech, for letting us use these wonderful facilities. This morning's topic is programmatic resilience, and we've got 4 excellent presentations to close this out here. We're going to start off with Ken Ashe. Ken is a principal engineer with Wood Environment and Infrastructure Incorporated, where he serves as Wood's Deputy Risk Map Program Lead and Carolina's Water Lead. His background is a combination of program management, H&H modeling, flood studies, the NFIP, hazard mitigation, and emergency management, including positions in state government and the private sector. He supported North Carolina DOT hydraulics unit since 2006, providing H&H, disaster response, and recent resiliency initiatives. Ken is a professional engineer, project management professional, and certified floodplain manager. He currently serves as chair of the North Carolina Association of Floodplain Managers, as an advisory board member for the North Carolina Department of Environmental Quality and Natural Infrastructure Flood Mitigation Advisory Board. Ooh, that's a mouthful. Yeah. Where else are we on here? And he serves on the University of North Carolina Wilmington Coastal Engineering Advisory Board. Ladies and gentlemen, here's for Ken.
We were talking beforehand, that's too long of a bio, I apologize. So at least the presentation matches and is extremely long. So I hope everyone has been enjoying Hotlanta. I certainly have. I got to go out and see the Braves on Tuesday. Hopefully some of you guys did. Did anybody go? I know Amit went. Anybody else go? Oh, good, good. Much like the Braves, I bring that up because I'm a pinch hitter this morning. The original person that built this presentation, I want to give a little credit to, is Garrett Shields. He's our geospatial manager in the Carolinas. This presentation was his brainchild, and he was involved with every bit of the information that's provided in it as far as production and actually doing the work. Dr. Fang yesterday said, let's go back to reality. This is going back to actually what happened. And this is a little bit of a timeline of where we went from a particular point in time to where DOT's hydraulics unit in North Carolina has gone to try to do their second job. You know, they're still doing their day job trying to get TIPs out on the street, but you know, at night you've got to do that. Here's where it's going to flood. This is where the bridge is washed out. What are we going to do about it? So it's a little bit of a talk around that. And so forgive me, because Garrett does presentations with quotes in it, and so I obviously will talk to a supervisor about that to get that fixed. But the key thing here is what DOT is doing is they have a problem that they identified, and they're working on that, but they're not just thinking about what's happening today. They're trying to make sure that they build things that can help answer questions in the future. And that's where you really get a lot of synergy, and there's a lot of return on investment. And so going back in time, Hurricane Floyd happened in 1999. It was a flood of record. It surprised everybody. There was people on roofs. We never experienced that. Well, every so many number of years, we reset what the flood of record is in North Carolina. Matthew came along and blew Floyd away, and then Florence came along just a couple of years ago and rained for 4 or 5 days. And if you look at the 4-day rainfall in some locations, that was 3/4 of the PMP. So what we saw was almost unbelievable. It rivals what you saw in Harvey in Houston. And if you go back 15 years again, North Carolina Emergency Management made a big effort to start leveraging data and the information that they had produced through the floodplain mapping program. And they were outreaching during coastal events how many buildings they expected to flood and what the damages associated with that flooding would be. And so the emergency managers were kind of eating that up. It was a lot of really good information. And as you move forward towards current times, other parties started getting invested in that. It started being released in the media. They would actually show part of the platforms they have to talk about what was going to happen with the flooding. And the citizenry really started picking up on it because there was a number of times where EM's websites were crashing because of the web load coming in, the bandwidth issues with people trying to find out what was happening for them. So during Florence, there was a fateful press conference where the governor comes in, the director of emergency management comes in, all the secretaries from the departments to talk about what's happening during the storm and what to expect and how the citizens should react and what to expect. EM starts talking about all of the buildings that are going to be flooded, and they're talking about which state facilities should be evacuated. And then someone in the press corps asked the Secretary of DOT, Secretary Trogdon, well, what's going on with the roads? When will they be open? That was a novel question, had not been asked before, so there really wasn't an answer. So there was some frantic calls on a Saturday evening, I think it was, Matt, pulling in some industry help as well as all the hydraulic engineers at DOT. We showed up, some of our partners, Dewberry and HDR, showed up to try to help out. And since it was a question that had never been asked and everybody was focusing on design up to that, this is what it looked like. And what this is chaos. We were in a room that wasn't set up for a bunch of work to go. We're doing a lot of whiteboarding. We're doing a lot of GIS analysis on the fly, trying to answer questions as they popped up. We were given a mandate of you've got an hour to figure it out, an hour to do it. And that's not possible. And yes, there's a NCDOT roadmap there with Sharpies drawn on it saying here's where you can drive and here's where you can't based on what we know. And I won't say it was stressful, but I did account about half the people in that picture either no longer work for DOT, no longer do work for DOT, or do something else in DOT. And of course, there's Matt taking it easy, it looks like so. So what was our answer at the time? Our answer at the time was to do back of the envelope math, look at gauges, do extrapolation, answer the questions the best we could, and to tell the secretary there's 60% of the state you shouldn't be trying to drive in. But we couldn't tell them how long. That was a tough question. Over the days we were in the war room, we got a little better at that. And so that spurred DOT and really started making the hydraulics unit thinking about what they could do because North Carolina is a pretty data-rich state. And here's the quote that I don't like, but it's Henry Ford. So I've always been a Toyota driver. But the point is what Matt and his bosses and his colleagues started doing is thinking about what we could do. Looking to seeing what other DOTs were doing, what emergency management was doing, and trying to get a sense of exactly what the risks to the roadways were. This is a photo of I-40 at what should be peak rush hour. That's a bass boat. So that shows you exactly what the flooding looked like. Flooding goes on as far as you can see. And this is really about, okay, how do you go from that shock of that room to building something that tells you in a planning sense what could happen, but also in a situational awareness sense. And there was a couple of separate parallel paths that DOT's gone on, a number of different initiatives. There's some presentations this week by ESP and U.S. Infrastructure about Bridge Watch initiative that DOT's doing and FIME-T. Those are very specific initiatives that focus on specific locations, whether it's a bridge that's in Bridge Watch or a gauge at a certain location. And you'll see where we fit into that in a little bit. The first thing we did out of the gate is there was a flood resilience feasibility study on the two main interstates that were shut down for over a week. A lot of work went into that. It's your classic report, too large to read through, too large to be manageable. It includes a large number of roll sheets so that we could develop quantities and actually do takeoffs and do costing of what the alternatives would look like. Each site we looked at had multiple alternatives looked at, and it went from basically the coast in Wilmington up to a little town called Benson where I-40 meets I-95 and then back down to the South Carolina border on I-95. We also did look at, during the middle of the analysis, we added North Carolina 24, and it was important because that's one of our main military bases, main way to get equipment in and out. And so we focused on trying to figure out exactly what it means to think about planning for resilience for these type of roadways and what the alternatives look like. And there's a little joke in this in a second, but everybody in DOT was involved from the Secretary's office, and that was really important because the Secretary said in a press conference that we're never going to let those roads flood that way again. So there's one of your resilience options. 1,000-year storm. So the map on the right is from Division 3. There was 3 divisions that were impacted most heavily. Storms are large, but they actually only affect a certain piece of the state each time. And that's Division 3, where they were hand drawing where the flooding was and what the depths were. And unfortunately, it's red, so it's a little hard to see, but there's red blobs all over the place. It was important to have the feasibility studies unit and others to help us with pricing, because we priced a fair number of alternatives through this. So key takeaways, key things is, we met with the divisions, we did field visits with the divisions, and part of the feedback we got from that is photos of the flooding, showing where the flooding was, estimates on how deep it was, and how long it lasted. And when we started talking about how long it lasted, that started spurring the conversation about resilience. How long do you let it flood? How long is it flooding when it makes it a problem? There was field visits. You see in the middle that we were supposed to do designs that made sure that Hurricane Florence, which was 3/4 of the PMP, wouldn't flood that road again. So those were pretty expensive options. The hydraulics units did a lot of thinking, and instead of doing the 50-year design storm on the interstate, they decided to step it up a bit and do the second alternative as a 100-year with 1.5 feet of freeboard. And I'm kind of proud of it. There was some people talking about being excited about being with projects. I-95 is under construction, so to speak, right now. It's in design and under construction through this area to be expanded. And hydraulics made the leap and started enforcing this 100-year plus 1.5 foot freeboard in those projects. Now, some of them were already too far gone, so they had to do assessments. But there are sections of I-95 being built now that are being built beyond the 50-year design based on what was seen here. The improvement options that are shown here are what you would expect. Let's elevate the road, let's build bigger conveyance or a combination. We looked at some roadside barriers where the flooding levels were low, including even considering the temporary barriers that South Carolina did. I don't think DOT in North Carolina was really keen on that. Obviously, drainage improvements. And we looked at connectivity and mobility, alternate routes. Would it be cheaper to improve a route that runs along the ridgeline, even though it's smaller, just so that we can get traffic in and out? Unfortunately, I-95 doesn't have that option. It cuts right through the state, and there's no parallel roadway. It's all small roads. I-40 does have a few good options. And I purposely leave off some of the bigger alternatives. There was an alternative developed by others to rebuild the river in another location around a town. That's a pretty substantial mitigation. There was even a hammerhead option to elevate traffic above about 10 miles of roadway in the town of Lumberton by building hammerheads, elevating the road in the median of the interstate. That was really ridiculously expensive and really not even really feasible, so I don't show it here. Large document, a lot of roll sheets, a lot of information. So we built an ArcGIS website with a portal to display the information. It's essentially a digital executive summary that's clickable. And what was cool about that is when we had to go in and brief the secretary at the end of the project, this is what we took in. We did not take a PowerPoint where we tried to work through what happened. We didn't take a copy of the report. I think Matt had one in his lap, but that was really a security blanket. But what's cool about it is you can click across the top, much like any dashboard, and you can choose the alternative or the route that we're talking about. The mile markers where the alternatives were done is on the left. You click those, and then the options pop up. You click the options, and you start seeing links to the roll sheets and the damage estimates. So it's a one-stop shop containing everything there. The right has metrics showing what the alternative cost would be, what the roll-up for the whole roadway or the whole alternative would be. There's a sister project dashboard that has more information in it, but DOT keeps that kind of close to home because the dollar amount of all the alternatives is a little hard to explain because it's so large, considering all the alternatives. So as that was going on, other initiatives were happening. The realization that using data and doing things in a digital environment was really the way to start being better prepared during events. It's a very data-rich state. LIDAR's been flown a lot of times. It was mentioned earlier in the week that there's a road ribbon of LIDAR in the state that tells you exactly the elevation along the road. Luckily, Faith over in the asset management group at DOT had recently completed survey on all of the conveyance features on the 70,000 miles of DOT roadway. So a very rich data set. So there's a lot that you can do with that if you start combining. That's our favorite roadway at the coast, Highway 12, that what's it take, a 2-mile-per-hour wind to push the surge up and flood it. And so we were tasked with to augment and complement what Bridgewatch and Fireman T was doing and try to get an answer on a wide area. And of course, you have to use a little bit coarser information. You have to step away from real-time information to do that because that's kind of the holy grail to do that. So we took and built a dashboard that answered the question of which roads will flood, which segments of the road will flood, how deep will they be, and what type of roads are those? Why is it important? Is it an evacuation route? Is it an interstate? And you can see, and I'll show more there in a second, that there's metrics on the side. Really what we did is we took the floodplain mappings data where they had studied and done recurrence intervals from the 10 all the way up to the 500 year in most places. In some places, they only went up to the 100. Took that and thought about how do we best build a really light and efficient platform that's not overcomplicated. So we thinned down the road network to only think about where it impacts the floodplain, and then took data, the road network from DOT, which is updated all the time, but the road network at the time, the LiDAR data that we talked about, the floodplains so that we could clip out the sections we were worried about, and then the raster data that contained the water surface elevations. This is a picture of downtown Wilmington in a very bad situation. It's the USS North Carolina. And this is the access from US 74, US 421 into Wilmington from the west. And it shows that if you start pushing the water up, most of downtown Wilmington's wet, but you can't get in and get out anyway. We did step away from using polygons for display and line features. We did point features to help keep the application really light, and we just spaced out the points inside of the floodplains every 50 feet and used those as a receptacle to store information that we needed for display. And I'll show those in a second. We did about 15,000 miles. There is a gap. The floodplain mapping program hasn't studied every stream in the state. So there's locations where we don't know what the flooding would look like. Even so, about 10% of the road network has information on it about what the flood level would be at a 10-year or 25-year on up floodplain. EM is doing some other things that can add to that, but we'll talk about that in a little bit. And it was just a simple storage of information. We stored ground elevation, the type of route it was, what the water surface elevation was, and then depth. Depth was really the key thing because you've got to think about, can a car go through it, can a high-rise vehicle go through it, or should no one try to drive through it? We built in the typical dashboard functionality you'd expect to see. You can clip and ship data out of it if you want to store the data in the points. You can export to a KML or a CSV, so you can make a shapefile if you want to use that particular view at a time in a different application. And PDF functionality so that if you need a hard copy as your safety blanket when you go in to brief the secretary. This is what it looks like, a classic dashboard. On the left, there's buttons where you can choose. I would like to see before the storm comes what a 10-year or 25-year or 50-year flood event would look like in a geographic area. You can choose county. You can choose division. You can even choose a route. So if you want, you can have the metrics pop up telling you how many miles of road are flooded at each flood increment, or what type of road has what impact. You can go from Wilmington all the way to the Tennessee border on I-40 if you choose to. And so it's a quick and easy. The display is very similar to if you saw the Feynman T presentation, the way we color code on roadways. This is the road that goes from the southwest out through the north is Lumberton. That was one of the roads that flooded for 7 or 8 days in both hurricanes. And you can see by the color coding large sections of that are underwater just in the 100-year flood. Using the same approach, we did build a application to display coastal flooding. It uses the same information, except it's a little bit simpler because it's 8 feet of surge or 10 feet of surge. The really complicated thing here was DOT asked us to assess what surge elevation do we show, how high do we go. And we knew that Hurricane Hazel in 1954 hit Brunswick County and had a surge of about 18.5 feet. And that's kind of the high bar in North Carolina. But a decade or so before the storm, North Carolina had redone the AdCirc storm surge study of North Carolina and found that in our large estuarine system in the northeast part of the state, where you have very shallow bays and very wide rivers with lots of tributaries and endpoints, that if you get a strong wind in the right direction, you really can jack and stack a lot of water up. And unbelievably, that modeling theoretically said that we could get surges up to 35 feet. So that's a real quandary. Do you build a platform that shows that you might see 35 feet of flooding in the southern counties and the northern counties? And how do you build an easy application that would show it's only going to be able to go to 35 feet in this location? So what we did is just did the simplification. The website displays from 1 to 17 feet of surge. But so that we didn't get caught unaware again, DOT has the data in the background, not on the website, that can tell them what roads would flood at what depth from 18 up to 35 feet. For us, it's a surprise. We consider ourselves to have 20 coastal counties. When you start thinking in this term, there's 23 or 25 counties that are actually coastal, just based on how much the water pushes up. We put a little bit of hindcasting in it so you could go back and look and see what certain hurricanes look like. IASIS at the bottom was just a simple little Category 1 storm, but it did do a lot of damage on the southern coast with surge. So they're in there so you can do what ifs and do planning. You can also use it to think about things like nor'easters and king tides. We're starting to see a lot of problems with king tides in North Carolina now. And like typical dashboards, you can hang other RSS feeds over the top of it, like weather data or the hurricane track. And it does the same metric coding on the right to tell you roads impacted. This is just a thing we tried to provide a little bit of insight for DOT. I'm not sure how they're using it, and we just looked at which roads flooded during multiple events. Did it flood during event 1 or event 2? And we thought about the depth to try to identify which roads were kind of at the most risk. But if you look at it, the ones that are most risk are right by the water, so I'm not sure of the utility of what we did there. So we've got a couple things that we worked on. There's other platforms we did. DOT has other supporters doing other applications. So we thought it'd be a good idea to hang all that in one location, a one-stop shop. So we built what we call RAFT. And like any good state agency or a consultant that supports them, we started with the acronym and worked backward to the words. So don't think about what it says. But what it really is meant to be, it's a secure login. You have to have an NCID login to get into it. But it allows you to go to one spot and see all the different applications. What's hidden down there is there is an application that took some engineering data from some other studies, and it has the moment of lifting for all the coastal bridges, and that's color-coded when pulling the surge from real-time other sources that do real-time surge. It tells you whether or not that deck's getting wet, and you can start worrying about the moment of lifting on that. And because of that and seeing that, they have actually gone back and done some strapping on some of those bridges. And these applications are starting to be used by EM as well as NCDOT. They were used during a couple flood events, a couple storms that came up. And Garrett wanted to make sure that I made the slide, what's the point? The point was when we went into the event and came out of the event, we realized there was gaps, both in planning and both in situation awareness. And despite being very data rich, because the question had never been asked, applications had not been built or data had not been combined in a way that really made it useful to think about what could be happening with the roadways. We're going through this. We also started seeing that EM had a lot of issues with bandwidth during the storm. They were actually not able to communicate at certain times. They had a lot of applications hang up. Their solution was to put in a second T1 line, which then overloaded all their systems during the next storm. So we started doing some of these applications out in the cloud to deal with that bandwidth issue, to free up the resources locally. And it can't be done. It's really important to understand that the relationship between DOT and North Carolina Emergency Management is kind of second to none. If you go back to 1999, when they formed the floodplain mapping program, the agency that built a lot of this data that makes this possible, DOT was there at the time. They provided financial assistance. They actually embedded an employee to help make sure the program would move forward a correct way. And since then, they have embedded employees over in EM. They continued sharing data openly. Data comes both ways. DOT actually shares all of their bridge project data with emergency management. So it's a really good relationship, and the consultants for both teams can be shared back and forth. And in North Carolina, an old friend of ours had a term called co-opetition, and we're still held to that. And that's where, when you're working with other consultants, you have to show what you're doing. You have to share it. And if you have problems, you have to openly discuss how to get rid of those problems. And that leads to a much better set of solutions down the line. And firms like Atkins and Dewberry and AECOM and ESP, along with us, have worked together in that environment for a long time. And without that willingness to do that, you don't get the opportunity to work on data that then gets used by another team to build an application or vice versa, or to improve an application. And that there's really a lot of synergy that's happened in the state because of that. Looking ahead, we have that classic problem because data is a timely issue. It has two dimensions. The road inundation tool is on older LiDAR. There's new LiDAR, so it begs the question, do you need to update the roadway network to reflect the latest data? NCEM recently did 2D modeling, watershed-based 2D modeling in about 80 Huck 10s in the eastern part of the state. We've been talking with DOT about maybe doing a pilot study to figure out how to incorporate that data, but there's a real big problem. The 2D modeling overlays the 1D modeling that's already been completed and been used, and if they don't agree which one is the best information, try to relay, this is what you're going to experience. So that needs to be figured out. The raft application I showed, the state's in the middle of putting that on the state-owned Amazon Web Service. That's a first for emergency management, so that's going really smoothly. So hopefully that'll be done soon, and that'll actually be a government site that they can have full control of instead of it being, what we did was pretty much a proof of concept. This is a picture, I think it's appropriate to end with a picture in Lumberton on 995, and this is what it looked like. And this is what it looked like for, 8 days, Matt? There is a billboard that it says, if you have a job and you've got $149, you can get a car. I assume that's for that water-damaged Jeep right there, but let's hope not. So with that, I'll stop and take any questions.
Any questions for Ken?
Going once.
Thank you very much.